The method I'm going to demonstrate is soil stability. The soil stability test provides information about the degree of soil structural development and erosion resistance. It also reflects soil biotic integrity because the organic matter that binds soil particles together must constantly be renewed by plant roots and soil organisms. This test measures the soil stability when exposed to rapid wetting. The first step is to randomly select sampling locations along the transect line and record these sampling locations under the position column on the data form. At least 5 centimeters away from the tape, determine the dominant cover class above the sampling point. Cover classes may include no perennial canopy, shrub, or grass. Record the stratum under the veg column on the data sheet. Excavate a trench approximately 3 centimeters deep. Insert the scoop horizontally approximately 5 millimeters below the soil surface and take the sample in your hand. Cut the fragment down to the appropriate size, 2 to 3 millimeters deep and 6 to 8 millimeters wide. Once the fragment is the correct size, take the sieve, take a dry sieve from the box and gently slide the sample into the sieve and place it back in the box. It is important to always keep the sample upright in the sieve from the time that you sample it until the time that you run it. To take the subsurface sample, excavate the trench to approximately 5 centimeters. The subsurface sample should be directly below the surface sample. Carefully dig down to a depth of 20 to 25 millimeters until a shelf is formed. Again, take the scoop horizontally. Take a sample that is larger than what you need. Cut it down to the appropriate size. Remembering to keep it upright at all times. And gently place it in the sieve. And gently place it in the box. Once you've collected your samples, gently fill in the hole that you've created. If the random sample point falls directly under canopy, such as grass, gently pull back the vegetation and take the sample directly beneath. If there's a case when there is shrub over grass canopy, record the stratum on the data sheet as a grass cover. If there's litter present on the surface, gently scrape it away so that none is included in the sample. If the sample flips, make sure you flip it back upright in your hand. In the case where your sample point falls under a shrub canopy, you want to make sure you get as close to the point as you can. Okay. Move the canopy aside, and in this case there's litter, so gently scrape away the litter from the soil surface without disturbing it. And take your sample. If the soil surface is unconsolidated, has loose grains, or will not hold together with a soil crust, it is necessary to spray deionized water onto the surface. Depending on your bottle, spray 5 to 6 times. You don't want to saturate the surface, but get that 2 to 3 millimeters wet, and then take your sample. If your sampling point falls on a rock that is greater than 5 millimeters in diameter, record an R on the data sheet and move to the next sampling point on the line. It is important to remember to always leave the lid of the box open while you're collecting your samples, as well as transporting the samples from the end of the transect back to the sampling site. To start the test, you're going to place the first sieve into the first cell of the box. As soon as the sieve hits the plane of the water, start the stopwatch. It should take 1 second for the sieve, as soon as it hits the plane of the water, to reach the bottom of the cell. Watch the sample for the first 5 seconds. If 50% of the structural integrity is lost, it is rated as a 1. Continue to watch the sample from 5 until 30 seconds. If 50% of the structural integrity is lost between this time, the rating would be a 2. The stability class will be rated as a 3 if 50% of the structural integrity is lost between 30 and 300 seconds or 5 minutes. At 5 minutes, regardless of whether the samples have been rated a 1, 2, or 3, all of the samples must be dipped. The rate of the dipping is very important. It should take 1 second for the sieve to come out of the box and clear the water, and 1 second to go back just above the bottom of the cell. After 5 dipping cycles, if 10 to 25% of the soil remains on the sieve, it is a class 4. If 25 to 75% remains, it is a class 5. And if 75 to 100% remains, it is a class 6. I'm now going to run through a whole box of samples, which means I'm going to be putting 1 sample in every 15 seconds. Start the stopwatch when the first sample touches the water. From the time the sieve screen touches the water surface to the time it rests on the bottom of the box, 1 second should have elapsed. At 15 seconds, put the second sample in. If it sticks to the side, gently push it away. At 30 seconds, put the third sample in. Continue to watch the second sample. Follow the sequence of immersions on the data form, adding 1 sample every 15 seconds. When you add a sample into a cell, remember to watch the previous 2 samples for a rating of 2 because you are still within the 30-second time window. After 5 minutes of soaking, raise the sieve completely out of the water and then lower it to the bottom without touching the bottom of the tray. And rate the sample when it is still under the water. It should take 1 second for each sieve to clear the water's surface and 1 second to return to near the bottom of the box. It should take 10 seconds to dip the sieve in and out 5 times. Give the sample a rating, blow out the sieve, and move on to the next sample. Watch the sample for the first 5 seconds. If 50% of the structural integrity is lost, it is rated as a 1. Continue to watch the sample from 5 until 30 seconds. If 50% of the structural integrity is lost between this time, the rating would be a 2. The stability class will be rated as a 3 if 50% of the structural integrity is lost between 30 and 300 seconds or 5 minutes. After 5 dipping cycles, if 10 to 25% of the soil remains on the sieve, it is a class 4. If 25 to 75% remains, it is a class 5. And if 75 to 100% remains, it is a class 6.